Hi, good morning, students. We discussed in the last class about friction and different types of friction, the coefficient of friction, etc. We have seen that the cause of friction is due to the roughness of the surfaces in contact, which are in relative motion with respect to one another. So, that irregularities or that rough surface, they will get interlocked, and that causes the further motion. So to reduce that friction, we have to fill in that irregularities that may be interlocked by applying some smooth fluids like oils, some fluids. We can remove that roughness or irregularities, and we are reducing that friction. Such materials used for reducing the friction are called lubricants. Air lubricants, fluid lubricants are also used as such. And here today we are discussing about uniform circular motion. Uniform circular motion. See, uniform motion we have. What is uniform motion? An object cover equal amount of distance in a very equal interval of time. So its magnitude of speed is very constant. Its magnitude of speed is same at any instant of time. It is called uniform motion. Now it is circular motion. The path followed by the body will be along a circular track, and it is circular motion. So now what is uniform circular motion? When an object follows a of circular path at a constant speed, it is uniform circular motion. When an object follows a circular path with a constant speed, it is called uniform circular motion. For example, the electrons that revolve around the nuclei, it is at a constant speed in a particular orbit, so it is uniform circular motion. And you might have seen that the satellites, they are at a constant height above the earth's surface. It is also in a uniform circular motion. And a car moving along a circular track or circular road with a constant speed, it is also in a uniform circular motion. And actually, though the speed is constant, there is the change of speed or the change of velocity at every instant will be different. See, when a body is in a uniform circular motion, the velocity direction is different. The velocity will be in a direction perpendicular to the, in a direction along the tangent to the point where we measure the velocity. For example, at this point P, the velocity direction will be the tangent to the point in the direction of motion or in the direction of that speed of that body along the circular orbit. So see, this is the circular path. If you are finding the velocity at this point, we have taken a tangent in the direction of velocity of the body in that particular point. It gives the velocity of the body, direction of velocity at that point. So velocity at any point along velocity at any point in the circular motion is along the tangent at the point in the direction of velocity. And see, at a later time this point is reaching that P dash. There the velocity is again found as a tangent to that point P dash in the direction of that motion of the body. So you can see that since the direction of velocity keeps on changing, there is acceleration. Though it is uniform magnitude of speed, since its direction of velocity changes, it is accelerated motion, it is uniformly accelerated, right? And we can see that the average displacement between these 2 points is this one, from P dash to P, the average displacement is this much measure, and it is represented as dr. Okay, from P to P dash, let the average displacement is dr. Now here the point is sweeping, changing from P to P dash. So the radius swept a circular path, and from the interval P to P dash there is a small angular displacement, and let it be equal to d theta. Angular displacement from P to P dash that the radius swept out is expressed as d theta. It is the angular displacement. Right now, it is seen that the average velocity and the average acceleration in this uniform circular motion is directed towards the center. It is directed towards the center. That is, the average velocity and average acceleration will be perpendicular to the average displacement in that motion. Or in short, we can see that at any point, at any instant in a uniform circular motion, the acceleration is acting directly towards the center of the circular path it has followed. That is the centripetal acceleration. During circular motion, that acceleration the body has suffered is always directed towards the center of the circular track. Okay, so we have two velocities, one along this v dash along this direction, and the v along this direction. So the average velocity we are taken it as dv. It is directed towards the center. Average acceleration, it is acceleration centripetal. It is also directed towards the center of the circular orbit. Now we have some relations regarding the angular speed, angular velocity with the linear displacement and linear velocity. We have angular speed equal to angular displacement by time taken. So here let the angular speed, not the linear speed, linear, not we are considering the linear displacement, that the angular displacement by time, it is called angular speed. It is given by the equation omega equal to d theta by dt. See, we have once discussed angle equal to, plane angle equal to, what is that, arc length by radius. This is the arc length. Average arc length is from P to P dash, this dr, and the radius is, we are taken, let it be equal to r, small r, we are taken it as r. Radius of the path is r. Okay, so capital R, we are taken it as capital R itself. Okay, don't get confused with that. So we can see that dt equal to dr by r. So we can write omega equal to, instead of dt we are writing dr by r dt. Okay, so dt is dr by r, then dt at the denominator we have. What is dr by dt? Linear displacement by time. It is linear velocity. So we can write angular speed equal to v by r, or v, the linear velocity related to angular velocity omega, as v equal to r omega. V equal to r omega. Similarly, we can write the angular acceleration is equal to v square by r. Again, we are finding that relation related to linear acceleration as angular acceleration equal to v square by r. In this manner, we can find the angular acceleration. See, here the force is F equal to m into acceleration, that is m into v square by r. F equal to m v square by r. Since the acceleration is directed towards the center, the force experienced by the body is also directing towards the center. That means the force which maintained the object along the circular orbit during the circular uniform motion, it is directed towards the center, and hence it is known as centripetal force. The force which makes the body always along the circular track, and that force is directing toward the center of the circular track it has followed, it is known as centripetal force. The expression for centripetal force is m v square by r. That is, a body of mass m is moving with a velocity v along a circular orbit of radius r, then the centripetal force directing towards the center of the motion, center of the track is given by mv square by r. You know, for maintaining a body along a circular orbit, this centripetal force is compulsory. It is important and it is compulsory. As long as the body is not maintained that centripetal force, it will be thrown out of the circular path it has maintained. So that is why during movement of rotating a stone with a thread using your hand, as long as you are just releasing that hold on the thread, what happens, the centripetal force is removed, so the stone is thrown away from the circular that path it has followed. And to maintain the vehicle along a circular track, we require sufficient centripetal force. So either by making that vehicle like bike towards the tilted towards the center of the circular road, or by making some arrangements like rising the outer edge of the road a bit above the a bit more than the inner edge, it is called banking of road, which is used to maintain the circular motion of that particular object along the circular path. Okay.